Hi students, very good evening everyone. Welcome once again to Om Institute and welcome once again to the control system concept through PYQ sessions. All right, very good evening everyone. Good evening Sai Vikas, good evening Sharma. Okay, so as you know, we have been taking several topics from control system and revising and learning those topics with the help of important PYQs. Okay, maybe some recent years, maybe some old years, but the important PYQ, something that will teach you, something that will give you some lessons. Okay, good evening, Chitra. Okay, and today we'll be continuing the same control systems, but the topic for today is Bode plots. Okay, as some of you were demanding, they have the session on Bode plots. Yes, today we are having the session on Bode plots. Very good evening, everyone. Come on, everybody, quickly keep on connecting. Okay. Right, let me just check it out. Okay, so I think the audio video looks fine at my end. In case of any issue, you can do let me know, dear. Okay. So here it is. Let's move towards the first question for the day. This is a brief intro about me, as you're all aware about. Okay. So first question of the day, old one, but yeah, a traditional question, and then we'll have some recent year questions also. But a very traditional question, given the Bode magnitude plot of a minimum phase system. Now, just to tell you in one line right now what minimum phase is. I hope you are aware about that. Very good evening, Sai Krishna. Okay, so minimum phase system is one in which all the poles and zeros are in the left half plane. Okay, minimum phase system would be one where all poles, not only poles, but zeros in left half plane to be considered. Okay, now the Bode magnitude plot of such a system is shown in the figure. What is the transfer function of the system? What is the transfer function of the system? Now, okay, let's learn about this. Okay, let's learn about this transfer function of the system. Now, what normally transfer function, what are the different terms a transfer function normally will contain? Okay, we would start, okay, say the GSHS has some gain term, okay, k, constant term k, into there may be some zeros, okay, simple zeros of first order, 1 plus st1, 1 plus st2. Just wait for some time. I'll also explain you if there is a zero or a pole of second order, then what happens. Okay, right, divided by s raised to the power n. Okay, that represents there may be poles at origin. Okay, into some simple poles, 1 plus sta, 1 plus stb, and etc, etc, etc. Okay, so that means to find out the transfer function, yes, it is in Hyderabad. Om Institute is office and offline classroom happens in Hyderabad. So that means to find out any transfer function, we need to identify what is this gain term k. Okay, how many poles at origin? Okay, how many poles at origin? S power n says that there are n poles at origin, and then if there are some simple zeros or simple pole terms, okay, the poles and zeros of first order. Okay, now dear, if you have a simple zero, 1 plus st, or a pole term which is like 1 upon 1 plus st, like 1 upon 1 plus st, okay, whenever there is a pole or zero, that brings a corner frequency. I will explain you with the question also. As I told you, this is the concept session through previous year question. Okay, this will have corner frequency. Okay, and that corner frequency will be given by 1 upon t. That corner frequency will be reciprocal of the time constant. We know that t is the time constant. Okay, the corner frequency is given by reciprocal of the time constant, 1 by t. Now, what happens at the corner frequency? Okay, at the corner frequency, what happens in the Bode plot is the slope change occurring. Okay, slope change occurs. How much slope change occurs? The slope change, okay, the slope change will be plus 20 decibel per decade. Okay, due to a single zero term. Okay, and the slope change will be minus 20 decibel per decade. Due to a pole term. Okay, due to a pole term. Okay. Now, so poles and zeros can be identified if there are some slope changes. So one by one, then we will come to n and k. Okay, one by one. So have a look into it. There is some slope, initial slope, which is 0. There is a significance of initial slope, I'll tell you. But moving forward, okay, this is initial slope, which is 0. Why I call it as 0 slope? Because it is parallel to x-axis. Parallel to x-axis means 0 slope. Okay, now here you see that the slope of the line changes. It actually increases. How much is the slope of this section? Let us calculate, dear, first of all, the slope of this section. So how much is the slope here? So as you know, the units of slope, okay, in the Bode plots are kept as decibel per decade. Okay, decibel per decade. So how much is the change in decibel magnitude? How much is the change in magnitude? See, 120 to 140, 120 to 140. Okay, so that is like 140 minus 20 is the change, okay, in decibel. Okay, for how many decades of frequency? When you actually draw it on log paper, we take this x-axis as the log omega axis. So how many decades of frequency? 0.1 to 10. Now what is a decade? Decade means a factor of 10. Decade is a factor of 10. Okay, so 0.1 to 10 is like into 10 into 10. So into 100. This is like into 100. And into 100 means 2 decades. Because the factor of a factor of 10 time, let me put it this way only, okay, is known as decade. Okay, so this is into 10 into 10 into 10, 2 times into 10. So that is 2 decades. So how much is the slope of this line, dear? Then this is 120 divided by 2, which is 60 decibel per decade. Which is 60 decibel per decade. Okay, how much is the slope here? How much was the initial slope? Is 0 because it is parallel to x-axis. Okay, the slope which was 0 suddenly changes to 60 decibel per decade. 60 decibel per decade. Okay, 60 decibel per decade. Correct? Now, as I told you, there is a slope change of plus 20 decibel per decade due to a single zero. Okay, due to a single zero. But here there is a slope change of 60. So if there is a slope of 60 here, let me highlight the slope change now. Okay, so what happens here? Okay, here there is a slope change from 0 to 60. There is a slope change of 60. That means how many zeros are located here? Because it is plus 60 zeros, but how many zeros? 3 zeros. Okay, how many zeros? It is 3 zeros. Okay, it is equivalent to 3 zeros. Okay, and at what frequency? 3 zeros at omega equal to 0.1. Okay, and this is known as the corner frequency. This is known as the corner frequency. So now, dear, that means when I start writing GSHS, see, dear, when I start writing GSHS, I'll explain you other terms also. Okay, there will be some K term, okay, that I will explain later. But how many zeros? Okay, 1 plus ST, where T, the corner frequency is 1 by T, means the time constant is 1 upon corner frequency. Time period is 1 upon corner frequency. So what is the corner frequency we have got right now? 0.1. But how many zeros are located here? 3 zeros. That means this factor will be repeated 3 times. Clear? Then let's go to the next, step by step. Let's go to the next, okay? Now, what happens here? What is the slope of this line? How much is the slope of this line? So let me write down directly. The previous one I explained you by subtracting and etc. Now look into it. 140 to 160. Okay, so how much is the decibel change? 20 decibel. Okay, per how much decade? Okay, now see, 10 to 100. Here from this point to this point, frequency is 10 to 100. That is into 10. That is 1 decade only. That is 1 decade only. Okay, so this slope is 20 decibel per decade. Now, important thing is how much is the slope change here, dear? How much is the slope change? That is the important point to be noted. How much is the slope change? The slope was 60, now becomes 20. That means slope actually decreased. Okay, that means slope actually decreased. I can say that here there is a slope change. Here there is a slope change of minus 40. Can I say that, dear? There is a slope change of minus 40 because it was 60 becomes 20. That means reduced by 40. So there is a slope change of minus 40 decibel per decade. And that too, as I told you, there is a slope change of minus 20 decibel per decade due to a single pole. Okay, so this will be representing actually 2 poles. 2 poles at what frequency? 2 poles at what frequency? What is that frequency? This is omega 10 at omega 10. Okay, now there are 2 poles at omega equal to 10. Okay, there are 2 poles at omega equal to 10. Okay, so divided by s power n. K and n, just wait, I'll explain you that also. Then there are pole terms, okay, in the denominator, 1 plus sta. What is that ta? What is the time constant? 1 upon corner frequency. What is that corner frequency is 10. Okay, so 1 plus s into 1 by 10. And how many such poles? 2 poles. 2 such poles are there right now, correct? 2 such poles are there. Okay. Next. Now look into it. Again, here there is going to be a slope change. Again, there is a slope change here. So how much is the slope, dear? Finally, this line is again parallel to x-axis, so 0 slope. Okay, because it is having 0 slope. Okay, so let me write down the slope change. How much is the slope change here? How much is the slope change here? Okay, it was 20. Okay, this slope was 20. Okay, now becomes 0. That means again reduced by 20. Again reduced by 20. So there is a slope change of 20. Minus 20 because there is a reduction. Minus 20 decibel per decade, and that means 1 pole. Okay, because slope change of minus 20 decibel per decade is due to a single pole. Okay, single pole at what frequency? What is this frequency? 100. What is that frequency? Is 100. Okay, everything I'm writing within the plot also, so that later on you can refer to the data. Okay, so there is one more pole. Okay, and 1 plus st. What is t? 1 upon corner frequency. What is corner frequency? 100. So 1 plus s by 100, power 1. Power 1. 1 plus s by 100 power 1. Okay, fine, dear. Okay. Now, after that, there is no more slope change. Okay, so I have calculated how many poles and zeros are there. Step by step, I'm going. First question it is, na? Okay, now come to the next part. What is k and n? Okay, what is k and what is n? Okay, for that, let's talk about the initial part formula. Okay, let's talk about the initial part formula. Okay, what is the initial part formula? Initial part. Now, initial part means, what do you mean by initial part? Okay, initial part means from the starting up to whatever is the first corner frequency. Whatever is the first corner frequency. That part of the Bode plot will be known as initial part, and the formula will be given by minus 20 n log omega plus 20 log k. The magnitude of initial part will always be represented by the formula, will always be represented by the very important formula. This is important for you actually. Minus 20 n log omega plus 20 log k. Minus 20 n log omega plus 20 log k, where n, as you saw here, n is what? Is the number of poles at origin. N is the number of poles at origin. Okay. That also means what is the initial slope? Now magnitude is plotted on the y-axis. Now this is like the formula. What is y-axis? Okay, this is y-axis. And what is on x-axis? In the Bode plot, x-axis means log omega. So this is of the form y equal to mx plus c. Straight line. Okay, straight line. So in that straight line, what is the value of the m? What is the value of the slope? That will be known as initial slope. Slope of the initial part. And that is given by minus 20 n. And the unit, as we know, is decibel per decade. Minus 20 n decibel per decade. Okay, minus 20 n decibel per decade. Fine. Okay, so Sai Vikas says answer A. Let's check it out. Minus 20 n. Acha, one more thing, dear. Okay, this is what I have considered poles at origin. Okay, if there are zeros at origin, rather than pole, if there are zeros and suppose m zeros at origin. Okay, if there are m zeros at origin, then the magnitude will be given by the formula plus 20 m log omega plus 20 log k. Okay, that will be the magnitude formula if there are zeros at origin. How many zeros? M zeros. And in that case, what is the initial slope? We will take those problems also. In this case, what is the initial slope? Is plus 20 m decibel per decade if there are zeros. If there are zeros at origin, right? Okay. Now, dear, let's go back to the graph. Let's go back to the graph. Okay. So what is the slope? This slope means this is the initial slope, beginning slope. Okay. So this slope, which was 0, is the initial slope. And because initial slope is 0, what is the initial slope formula? minus 20n. Initial slope 0 means n equal to 0. Means this factor n equal to 0. Okay. So now dear, if n is equal to 0, okay, what is the magnitude formula? See, what is this magnitude formula? Magnitude is minus 20n log omega plus of 20 log k. Okay, but as I'm telling you here, n is 0. So what is the magnitude? Initial magnitude will be constant, 20 log k. And as you're able to see, yes, initial magnitude is constant. It is a constant value of 20. It's neither increasing, decreasing. Initially, up to the first corner frequency, it is constant. Okay, so how much is that constant value? 20 is equal to 20 log k. Okay, so that means log k is 1. So what is k? This is log to the base 10. So if log k is 1, k should be 10 power 1. That means k equal to 10. That means k equal to 10. So now here I can put down k equal to 10 and I can put down n equal to 0 and I can see what is the GSHS coming out to be. What is the GSHS? It is 10. Now see the options. Options are in which form? Options are in the form of s plus a, not in the time constant form. Okay, not in the time constant form. Okay, so we'll simplify this. So what do I have here? 1 plus s upon 0.1. That means s plus 0.1 divided by 0.1 whole cube is divided by s power 0, which will be just 1. So I'll remove it. Then I have s plus 10 upon 10 whole square, and next factor is s plus 100 by 100. So see, what is the overall, in this format, what is the overall constant that is going to be left? See, this is 10 square from denominator, that goes above, into 100. This 100 also goes above, divided by 0.1 whole cube. Okay, into the factor s plus 0.1 whole cube divided by s plus 10 whole square into s plus 100. Everything solved. See, this is 10 into, this is also 10 square. So 10 square, 10 square, 10, total 10 power 5. 0.1 cube. If you shift 1 upon 0.1, that also becomes 10. So another 10 power 3. So total 10 power 8. Okay, 1, 2, 2 and 3. Total 10 power 8. S plus 0.1 whole cube is divided by s plus 10 whole square into s plus 100. I went step by step slowly in this question. Okay, let me know if there are any doubts and let me also see what is the option that is turning out to be. Okay, so it is option number A. It is the option number A. Okay, it is what is the option number A. Okay, it is the option number A. Now dear, okay, see, this was the first question, so I have taken every calculation. What is K, what is N? But now I started actually, okay, by first the analysis of poles and zeros. Okay, whenever there is a slope change, there is the pole or zero at that particular frequency. Okay, so I started with this analysis. Where is that pole and zero? Yeah, here. I have explained you in the graph only. Okay, so what I come to know is there are 3 zeros at 0.1. Okay, there are 2 poles at 10 and there is another pole at 100. That means, okay, because there are 3 zeros at 0.1, that means there should be s plus 0.1 whole cube. That means there should be s plus 0.1 whole cube. Okay, so this option is ruled out. C is ruled out. Then there are 2 poles. Okay, then there are 2 poles at 10. So s plus 10 whole square should be there. S plus 10 whole square. So this is also ruled out. This is also ruled out. Correct answer is option number A. Correct answer is option number A. I did not tell you this earlier because I wanted to go in the complete flow of the problem. Okay, but only by the location of poles and zeros, we can say it is option number A. Okay, only by the location of poles and zeros, we can say option number A. Okay, what did I say? I can simply say that there are 3 zeros. I will put down this remark. 3 zeros at omega equal to 0.1. Okay, then there I notice that there are 2 poles at the frequency of 10 and then there is a single pole at the omega equal to 100. Okay, only and only option number A satisfies this much. That means K and not required for this question. Okay, not required for this question, but we have solved it. Okay, just to be complete, we have solved it. Okay, just to be complete, we have solved it. Okay, dear. This is what is the open loop transfer function obtained, right? Yes, Sai Vikas correct. Sharma correct answer. Initial slope, Sai Vikas, yes, will decide the type of the system if it is unity feedback. As I already explained you in the steady state error class, that the type is defined for unity feedback systems actually. Okay. So that only that point you have to take care. Okay, next question. Now next question. Acha, if you see overall, how many total poles and zeros? Total 3 poles and total 3 zeros. Okay. Total 3 poles and total 3 zeros. And as I'm telling you, every pole brings a slope of -20 and every zero brings a slope of +20. Okay. So that means finally, okay, what is the last slope you see here? The last final slope you see here is 0. Why? 3 poles. So 3 times -20. Total 3 poles, na? Wherever they are, but total 3 poles. And total 3 zeros. So 3 times +20. 3 times -20, 3 times +20 cancel, and that is why you see this final slope as 0. You see this final slope as 0. So sometimes you expect the questions on, on this point, final slope and final zeros, etc. Okay, so I'll put down these formulas separately for you. Yeah. So what is that final slope? Final slope. Okay, that means this is also known as final slope, also means slope at high frequencies. Slope as omega tending to infinity. And that final slope is given by the formula -20 into P minus Z decibel per decade, right? For every P. So what is P and Z? Is the total number of poles and zeros. Okay, P is the number of poles. Okay, Z is the number of zeros. Okay, so for every pole -20, P poles, so -20 into P. For every zero, +20. So this is why minus will become +20. How many times? Z times, because there are Z number of zeros. Okay, final slope. Okay, then what is the formula for final phase? Similarly, okay, what is the formula for final phase? The final phase will be given by -20 degree into P minus Z into degrees, in terms of degrees. Okay, P and Z is again the number of poles and zeros. Okay, number of poles and zeros. Yes, correct, Sai Vikas. Okay. So sometimes, there are fundamental questions expected only on this slope and final phase calculation. I will show you that, and then we'll come back to more such problems. Okay, we'll come back to more such problems. In case of any doubt, please do let me know. Okay. See, in the context of Bode magnitude plot, 40 decibel. Okay, slope conversion. There is another unit of slope known as decibel per octave. Okay, decibel per decade. Okay, decibel per octave. Decibel per decade, decibel per octave. Okay, let me explain you. What is octave? Octave is a factor of 2. Octave is a factor of 2. Okay. So if there is a line of slope 20 decibel per decade, let me explain with the 20 decibel per decade. And if you know the previous answer, please do comment. Okay, please do comment what is the answer if you know. So suppose I have taken a line whose slope is, okay, whose slope is 20 decibel per decade. What does this 20 decibel per decade means? That when the frequency, suppose this is frequency 1, let's assume, okay, let's assume that this frequency is equal to 1. Okay, suppose this is frequency 1 and suppose this is frequency 10. Okay, so this is what is 1 decade. Frequency change of 10 times is 1 decade. Now, what does 20 decibel per decade means? That whenever the frequency changes by 1 decade, the magnitude should change by 20 decibel. So this magnitude at this point, this should be 20. This is magnitude in decibel. This should be 20. Now in decibel per octave, if you know, you can comment. Sumit says that answer is B. Correct answer, Sumit. Okay, correct answer. So see what happens now. Octave means a factor of 2 times. Octave means a factor of 2 times. Okay, octave means a factor of 2 times. Okay, so this is what you mean by 1 octave. 1 octave. Okay, factor of 2 times. Okay, so at the factor of 2 times, how much is the magnitude? How much is the magnitude? So let's basically play with the slope formula. Okay, slope is how much? 20 decibel per decade. Okay, and slope, mathematically slope is given by, slope of any line is y2 minus y1 upon x2 minus x1. Okay, so what is y2 minus y1? Okay, what is the change in magnitude? 20 minus 0. Okay, what is y-axis? Magnitude. Okay, so 20 minus 0. What is x-axis? Remember, x-axis in Bode plot is always log omega. We write down, for simplicity, we write down omega value, but when we plot it in the semi-log paper, okay, we take the log omega here. Okay, so what is the change in the x2 minus x1? Okay, change in the x2 minus x1. Okay, so let us consider these 2 points now. Okay, if I consider these 2 points, it is 20 minus 0, but this magnitude is already known at 20. So let us consider these 2 points there, number 1 and number 2. Okay, so what is change in y2 minus y1? What is the change in magnitude? M minus 0. And what is the change in the frequency? Okay, change in the frequency in terms of log omega. So that is log 2 minus log 1. This is x-axis, which is log omega. So log 2 minus log 1, clear? x2 minus x1 means log 2 minus log 1. Okay, so from here I can calculate how much is the magnitude coming out. 20 log 2 minus log 1. What is log 1? Is always 0. 20 log 2, and here this is approximately 6 dB. This is 6 dB. That means this magnitude is 6 dB. That means I can say that whenever the frequency changes by 1 octave, then the magnitude is changing by 6 dB. Okay, that means this particular slope, which is 20 decibel per decade, in terms of octave, per 1 octave, how much is the magnitude change? 6 dB. Okay, a slope of 20 decibel per decade is equivalent to 6 decibel per octave. Remember, 20 decibel per decade is equivalent to 6 decibel per octave. So 40 decibel per decade will be equal to how much? If you double it here, so 2 into 6, that is 12. Option number B. That is the 12. Option number B is the correct answer. Okay. Right, Sumit, Sai, Vikas, Sharma, correct answer. Option number B, 12 decibel per octave in terms of octave. Okay, now look into it. A simple 1 mark question. Okay, just taking some basic questions, and then we'll again come back to the transfer function based question. In a Bode magnitude plot, which one of the following slopes should be exhibited at high frequency? Slope at high frequency. Okay, by a 4th order. Okay, all pole system. Now 4th order means how many poles? 4 poles. Okay, 4th order means order is decided by the denominator. Okay, so if you say 4th order, that means the denominator is s power 4. There will be 4 poles, and it means that all pole system. What is all pole system? All pole means there are no zeros. Okay, all poles clearly means that there are no zeros. So there are 4 poles and then there are no zeros. There are 4 poles and then there are no zeros. Okay, so what is the slope at high frequency? Okay. The slope at high frequency, also called as final slope, as I explained you, is given by the formula minus 20 into P minus Z. Okay, so 4 poles and no zeros makes it minus 80 decibel per decade. Makes it minus 80 decibel per decade. Option number A. Minus 80 decibel per decade. Option number A. Correct. Simple one. This is yes, Sumit and Sharma. Correct answer. This one is simple, but sometimes that is what we are getting some 1 marker question on the very basic things about Bode plot. Okay. Okay. Next question then. The asymptotic Bode magnitude plot of a minimum phase transfer function. See, gate 19 EE 1 mark. Previous one was I think EC 1 mark. Okay. Now the asymptotic Bode magnitude plot of a minimum phase transfer function is shown. Okay, and consider the following 2 statements. Statement 1 and statement 2 are given. Okay, the transfer function GS has 3 poles and 1 zeros, and at very high frequency the phase angle is minus 3 pi by 2. Which of the following option is correct? Okay, so now see, transfer function has 3 poles and 1 zeros. Okay, has 3 poles and 1 zeros. How can I say that? Okay, 3 poles and 1 zero. See, initial slope. This is what initial slope. Okay, the initial part up to the first corner frequency, because here there is a slope change, means it is the corner frequency. Okay, here there is a slope change. This is also a corner frequency. Due to what? Now you see how much is the slope change. First of all, this is the initial slope. Initial slope, okay, is minus 20n, which is minus 20. As per our formula, I told you it should be minus 20n. Okay, so n is 1. Okay, n equal to 1. What is n? 1 pole at origin. N is the number of poles at origin. Okay, so we have 1 pole at origin. We need to find out now how many poles and zeros. The statement 1 says 3 poles and 1 zeros. Okay, now see here. Okay, the slope minus 20 becomes minus 40. That means how much is the slope change? Again, slope decreased by 20. So this should be 1 pole. Slope decrease means it is a pole. Okay, I only want the number of poles. I'm not writing its respective frequency. Okay, then the slope is minus 40, minus 40, minus 40 up to here. Now the slope becomes minus 60. Now you see finally the slope becomes minus 60. That means again slope decreased by 20. Minus 40 minus 20 will make it minus 60. So this is also one pole. Slope decreased by 20 means it is a pole. Okay, so do you anytime see a zero? Do you anytime see a zero? No. So statement number 1 is false. Statement number 1 is false. Which of the option of statements is correct? True or false? That's what we have to see. The first is false. Okay, because there are 3 poles. Okay, that the GS has 3 poles and no zeros. Okay, now at very high frequency the phase angle. Now high frequency phase means, as I told you, high frequency phase means final phase, and which is given by the formula minus 90 degree into P minus Z. So 3 poles and no zeros makes it minus 270 degree, which is minus 3 pi by 2. 90 degree means pi by 2, so 3 pi by 2, correct. Okay, so this is true. This is true. Okay, this is true. So second is true, first is false. Option will be C. Statement number 1 is false, statement number 2 is true. Okay, so correct answer by Sumit and Akshay, correct. Okay. Yeah, that's what I explained. Sharma, minimum phase means, okay, where all the poles and zeros are in the left half plane. If some of the zeros or poles are in right half plane, that is non-minimum phase. Okay. Okay, so minimum phase means all poles and zeros are in the left half plane. That's what you have to remember as of now. Okay. I'm not going into details of minimum and non-minimum phase, just telling you the important conditions to check that. Okay, dear, next question. The magnitude and phase plots of a LTI system are shown in the figure. The transfer function. Now see, gate 23 EE 2 marks. This is a gate 23 EE 2 marks question. Now see here. Okay, the magnitude is entirely constant. There are no corner frequencies seen. Okay, it is just constant till infinite. Okay, what do you see here? Okay, there are no corner frequency. In short, I will keep writing CF. Okay, no corner frequency. That means no poles and zeros. Okay, no poles and zeros. Only initial part. Okay, and what is this initial part? Okay, what is this initial part? Okay. What is the initial slope? Is 0. That means n equal to 0. There are no poles at origin also, and then there are no poles and zeros anywhere else. Anywhere else. Okay, so what is the initial part formula? Okay, what is the initial part formula? As I have told you, what is the initial part formula? Magnitude is minus 20 n log omega plus 20 log k. This is what I have told you, but n is how much? 0. So what is the initial part? Is 20 log k. And if you see that initial magnitude is 8 decibels here. That initial magnitude here is 8 decibels. So what is the value of log k? Is 8 by 20, or which can be written as 0.4, correct? Yeah, 0.4. So what is the value of k? 10 raised to the power 0.4. Okay, that can be calculated using your virtual calculators. Okay, so how much it is? 0.4, na? Correct. So this is approximately 2.51. Okay, 2.51. So magnitude part is 2.51. Okay, now there are no poles and zeros, but still there is phase. Okay, so there may be a phase term, an exponential phase term. Okay, now you see the magnitude plot is given in log omega, but the phase is given in omega. Okay, this phase is given in omega and it's a straight line. Okay, it's a straight line passing through origin y equal to mx. Straight line passing through origin y equal to mx. What is y? Means phase. Okay, what is slope? I'll write down here. And x means omega. X-axis means omega here. So what is the slope? What is the slope? Okay, y, change in y upon change in x. So change in y is 60 degree, minus 60 degree actually. Okay, in terms of radian, minus pi by 3, and change in frequency is 1. Okay, minus pi by 3 upon 1. Okay, so what is this phase equation? Minus pi by 3 omega, or pi by 3 value. So pi is 3.14. Okay, so this is minus 1.05 omega approximately, minus 1.047. That is option number D is going to come. Okay, Because of this phase term, so how do you write down the transfer function normally now? Okay, how do you write down the transfer function? Gj omega hj omega in the frequency domain form. Okay, we'll write it as mod gj omega hj omega, the magnitude part, into e power j, okay, angle gj omega hj omega. Angle means that phase part. Okay, this is the Euler form, r e power j theta. Okay, so what is the magnitude? 2.51 constant. Okay, it is all constant. Okay, into e raised to the power, and what is that phase? Okay, minus 1.05, so e power minus j 1.05 omega, or in the s domain it will be written as minus 1.05 s. So option number D. Check it out here, it's option number D here. Correct, Akshay, it will not be B here, it is option number D. There is no pole. If there was a pole, see, this is totally to be discarded, because if there was a pole at s equal to 1, s equal to minus 1, that means corner frequency 1, okay, then definitely you will see a slope change at frequency 1, but there is no slope change. Okay, in the magnitude plot, there is no slope change in the magnitude plot happening. Got this idea? Okay, chalo. Do let me know if you have any other doubts. Next. Yes, Akshay, tell me the exact point which you want me to repeat. Tell me what exactly is the doubt. Okay. Chalo. Next question, gate 22 EE1 mark. Now see, Bode magnitude plot of a first order stable system is constant with frequency. Now it is first order. Okay, first order clearly means that it will have one pole. If it is first order, okay. Sharma, what is the exact point you please say? See, repeat. Always be specific with the doubts. That's a request, because if I repeat means I'll repeat in the same way, so then you can rewind the video and watch. So if you just tell me what point is not clear, I'll explain you in more better way. Repeating means will not help. You can rewind the video. You have the option in YouTube, you can rewind the video. So tell me, Akshay and Sharma, what exactly is the doubt you are having? Okay, in the initial part, to see, initial part is just constant. Okay, then that means the slope is 0. Okay, that means the slope is 0. It is parallel to x-axis, so n is 0. And because n is 0, the magnitude is only 20 log k. This is the initial magnitude. Okay, which is given to you as 8. Okay, putting the m equal to 8, I got the value of k. I got the value of k. Okay, then normally what do you say, dear? Normally what do you say? You say that the GSHS, the transfer function, will have some zeros term, etc., divided by s power n into some pole terms, etc. Okay, so n is 0 as I told you. Okay, will there be any pole or 0? There cannot be any pole or 0, because if there was a simple pole or simple 0, there will be a slope change of, okay, minus 20 or plus 20. Okay, minus 20 or plus 20. Okay, minus 20 or plus 20. But where is the slope change? There is no slope change. That means there is no corner frequency, no simple pole or 0. Okay, no pole or 0. Okay, so that means there is no 1 plus st, 1 plus st, only k term. But there is a phase. Okay, there is a phase term. Okay, if it was only k term, okay, then the phase is 0. Okay, but the phase is not 0. So that means there is a phase term, and e power j theta is known as the phase term. E power j theta is known as the phase term. Okay, and how much is that theta? I have explained you with the help of equation of line, because the phase is a straight line, so simple to find the equation, y equal to mx. Y equal to mx. Got this? Okay. Akshay, that is just calculation. Log k is 8 by 20 is 0.4, and then k is 10 power 0.4. That is done by calculator. This is just calculation part, Akshay. Magnitude 20 log k is 8. Why it is 8? Because you see here in the question it is given as 8. Okay, hope it is clear to you. The doubts are clear to you. Okay, moving ahead. Yeah, now look into this question. Again, the magnitude is constant. That means there is no corner frequency. Okay, here also you see no corner frequency, but is it the case there is no corner frequency? Okay, no, it cannot be the case of no corner frequency, because clearly the question says that it is the first order system. That means having one pole. Okay, having one pole. Okay, but there is no slope change. Now there are two things. Okay, in the magnitude plot, okay, in the magnitude plot, what do you see? In the magnitude plot, what do you see, dear? Is no slope change. In the magnitude plot, you clearly find that there is no slope change. Okay, now because there are no slope change, there is two conditions. Number one, there is no corner frequency as explained in the previous question, or corner frequency, or another condition, corner frequency of 0 equal to the corner frequency of pole. Okay, pole and 0 occurring with the same corner frequency. So what will happen if they have the same corner frequency? At the same frequency, pole will try to change the slope by -20. At the same frequency, 0 will try to change the slope by +20. Okay, and because of that, -20 plus 20, the net slope change is 0. Okay, no slope change. So that means if there is no slope change, that means either there is no corner frequency like previous question, or okay, or here there is a pole because it is first order, so there has to be a 0. There has to be a 0 also. Okay, and that too with the same corner frequency. There has to be a 0 with the same corner frequency. Okay, right. So that means now look into it. Initial part is 0. Okay, initial slope is 0. Initial slope, which is -20n, is 0. That means n is 0. Okay, n is 0. So what is the GSHS I will write here? Okay, what is the GSHS part I will write? Have a look into it. How much is the GSHS part I will write? GSHS will be written as k into 1 plus st1 divided by s power n into 1 plus st1. The important point is both of them should have the same corner frequency. Okay, normally we write 1 plus st1 and here we write 1 plus sta. But no, this ta, okay, and this ta, t1 should be same. Okay, same corner frequency means same time constant here. Same time constant. Same time constant. Okay, same time constant. Now see, what does it mean? Okay, first of all, rule out the option number C, 2 poles and 2 zeros. No, it is first order, that means a single pole. Okay, now if there is one LHP pole, okay, now if there is one LHP pole, there has to be one RHP pole or one LHP zero. Okay, that is what? Okay, one LHP pole. Okay, why one LHP pole? Because it is stable. Okay, stable means LHP pole. Okay, that transfer function is stable. Okay, so that is a LHP pole. Okay, now the 0 is RHP or LHP. Now you see, if you write down in this format, okay, what I'm trying to say is time constant or corner frequency is same. But if you write down in this format, then again there is no pole or 0. Then we come to the first case. But no, here there is a pole. Okay, so that means how will I write down? There will be a correction. Okay, the pole is 1 plus sta, 0 will be written as 1 minus st1. Okay, pole is definitely LHP because stable. Okay, so this means that there is a pole s equal to -1 by ta. Okay, so let's say same means t1 is ta is t. Okay, so pole is at s equal to -1 by t, and the 0 is at 0 will be at 1 by t. 0 will be at 1 by t. Symmetric pole and 0. Okay, symmetric pole and 0. Okay, symmetric pole and 0. Okay, so when you draw it now, actually, okay, there is a pole at -1 by t and there is a 0 at 1 by t. Okay, symmetric pole and 0, and then the system becomes an all-pass system. Now you see what is the meaning of all-pass system here. Okay, that means every frequency is passed with equal gain. The magnitude is entirely constant. The magnitude is entirely constant. That means any frequency, okay, will be passed with the same magnitude by the system. This is what is all-pass system. You have symmetric poles and zeros. And such a case is a all-pass. All-pass. Such a case is all-pass. Yeah, Govindra, we'll come to 24 gate also. Just kindly wait for that. Okay. So this is all-pass. This is known as a all-pass system. Okay, so anyways, what is the correct answer is, okay, one LHP pole is there, but where is that 0? The 0 cannot be at LHP, the 0 will be RHP, option number A, 1 RHP 0. Okay, not the LHP 0. Okay. Gate 22 doubly 1 mark question. Okay, so that means whenever you have the magnitude entirely constant like the previous question, okay, so there may be no corner frequency, okay, or if there are poles and zeros, then the corner frequency will be same. Symmetric poles and zeros. Symmetric poles and zeros. Symmetric poles and zeros. This is what it is. It is symmetric poles and zeros. That is symmetric poles and zeros. Okay. Sure. Let's move ahead to the next question. Come to this question. Gate 16 doubly 2 mark question. Okay. Consider the following asymptotic Bode magnitude plot. Which one of the following transfer function is best represented by the above by the below Bode magnitude plot? Okay, now dear, you see that, look into the initial slope. Now look into the initial slope. How much is the initial slope now? How much is the initial slope now? Okay, the initial slope is plus 20, positive. Okay, initial slope here is plus 20. And initial slope positive represents zeros at origin. Okay, represent zeros at origin. It should be compared with 20m. So m is 1. What is this m? 0 at origin. What is this m? Means 0 at origin. This means 0 at origin. This means a 0 at origin. Okay, this means what? 0 at origin. Okay, so m is equal to 1, 0 at origin. Okay, now that clearly means that, okay, option number B is ruled out. Okay, no, Govindrao, B is ruled out first of all because there is 0 at origin, not the pole. The 0 at origin means S in the numerator, not S in the denominator. So B is ruled out. Okay, now let's, find out. Okay, let's find out the corner frequencies here. Okay, what is this corner frequency? What is this corner frequency? Let's say this. Suppose this is omega 1 and suppose this is omega 2. Okay, omega 1 and omega 2. Now dear, I'll use a simple concept here, as I already explained you about slope unit. Okay, decibel per decade and decibel per octave. How much is the slope given to you? Okay, the slope that is given is 20 decibel per decade is also equal to how much? A slope of 20 decibel per decade is equal to 6 decibel per octave. Why I am using it? I'll tell you the logic also. Why I am using it? Because you see at this point, okay, you see at this point, how much is the magnitude? 0. You see at this point, the magnitude is 12. 12 means it is in multiples of 6. Okay, so dear, if there is a magnitude change of 12 dB, see 6 dB per octave, if I multiply by 2, means 12 decibel per 2 octave. Okay dear, I can write like this, na? 6 decibel per 1 octave means 12 decibel per 2 octave. So you see here, between these 2 points, how much is the magnitude change? 12. Okay, so how much should be the frequency change? How much should be the frequency change? Frequency change should be 2 octave. 2 octave. And what is 1 octave? Octave means a factor of 2 times, as I explained you. So what is this omega 1? Omega 1 is 2 octave. Okay, that is 2 into 2. 2 times 2 into 0.5, which makes it 2. Okay, omega 1 is 2. Okay. Acha, what is this? The slope was 20 decibel per decade, now becomes 0. What is this slope? This slope is 0. Okay, because this line is parallel to x-axis, the slope is 0. So 20 becomes 0. That means slope reduced. That means slope reduced by 20. That means this is one pole. That means there is one pole. Pole at 2. There is a pole at 2. Okay. So either 1 plus s by 2 or s plus 2 term should be there. Okay, s plus 2 term should be there. Okay, so that clearly says that. Okay, let me come to the 0 also, by the way. Let me come to the 0 or pole also. What is this? Here again, this is a pole only actually. This is also a pole only. Why? You see here, the slope is 0. Now the slope becomes minus 40. Now the slope becomes minus 40. That means there is a reduction of slope by 40. 40 means 2 poles. Okay, 2 poles at omega 2. Okay, 2 poles at omega 2. What is that omega 2? What is that omega 2? Let's work out again. How do I work out? To see dear. Okay, the magnitude 12 becomes 0 here. Look into these 2 points. Okay, the slope is minus 40 decibel per decade, and as I told you, 20 decibel per decade is 6 dB per octave. So 40 will be how much? 40 will be 12 here. Okay, so this is minus 12 decibel per octave. That means magnitude should change by 12, decrease by 12, minus 12. Na? Magnitude should decrease by 12 for 1 octave. Now you see, this is the magnitude 12. This becomes 0. Okay, the magnitude change is minus 12 only. So this should be 1 octave. This frequency change should be 1 octave. Okay, 1 octave means 8 is 1 octave. 1 octave means a factor of 2. Okay, 8 is twice of omega 2. So omega 2 should be 4. Omega 2 should be 4. So there are 2 poles at 4. There are 2 poles at 4. Okay, there are 2 poles at 4. Okay, so there is a single pole. Okay, there is a single pole. Okay, how much is the data we have got till now? There is a pole at how much? At omega 1. Okay, at omega 1 equal to 2, and then there are 2 poles. Okay, at omega 2, which is obtained as 4, correct? Omega 2 obtained at 4. Okay, and there is 1 0 at origin. That is the first thing I calculated. There, with the initial slope positive, there is a 0 at origin. That means, okay, my transfer function should be in the form of Ks. Okay, 0 at origin, and then there are poles. Okay, 1 plus s by 2 and 1 plus s by 4. This should be squared up. Okay, so what is the correct answer then? What is the correct answer? S by 2 means 0.5s and the other one 0.25s. Option number A. No need to find K. Do you think we require K? No, na? Option is matched. Option is matched. Okay, so option number A. If required, I told you how to find K. We know that method. Okay, but here not required. It is option number A. It is option number A. Okay. This is obtained directly by option number A. Okay. Okay, option number A. Done. Okay, so this was zeros at origin. The initial slope positive represent what? Zeros at origin. Okay. So before we come to another question, let me also take up a phase plot based question, gate 16 EC 2 marks. Okay. Yeah, we'll have some more questions, but let me tell you one more thing here first, Sharma, that is on the asymptotic Bode phase plot. The asymptotic Bode phase plot. How do you draw the phase plot? Okay, magnitude plot I told you. Okay. Standard form is 1 plus st. Okay, 1 plus st. Not 1 plus s by t, it is 1 plus st. Okay. S plus a can also be written, but normally if you want to talk about standard form, it is 1 plus st. Okay, but then you have to see in the options. Sometimes s plus a options may also be given. Options not necessarily coming in the standard form. In the previous question, it was standard form, Govindrao. Okay, so now asymptotic Bode phase plot is given to you. Okay, with k and p1 both positive, what is the value of p1? Now dear, okay, let me explain you first the important points here. Okay, whenever you have a zero term, that is 1 plus st. Okay, what happened? Okay, what happened? The corner frequency, okay, the corner frequency due to this term is 1 by t. Okay, is 1 by t. What happens in the magnitude plot? In the magnitude plot, slope changes by plus 20. Okay, if I talk about magnitude plot, slope, in the magnitude plot, there was a slope change, okay, of how much? Of plus 20 decibel per decade at this corner frequency at the omega c. This is what we know. This is what we have been using in the previous question. But if I talk about the phase plot, okay, there will be slope change, okay, but not at omega c, okay, not at omega c. There will be a slope change, okay, there will be a slope change of number 1, okay, okay, there will be a slope change of plus 45 degree per decade, okay, plus 45 degree per decade. This is 0 I am starting with, na, correct, or minus 45 degree per decade. There will be a slope change of plus 45 degree per decade, okay, at the frequency which is 1/10 of the corner frequency, okay, and there will be a slope change of minus 45 degree per decade at the frequency which is 10 times the corner frequency, at the frequency which is 10 times the corner frequency, at 10 times the corner frequency. Okay, this is what is going to be the slope change of minus 45 degree per decade, plus 45 degree per decade, or minus 45 degree per decade. Okay, plus 45 or minus 45 degree per decade. Just a second. Is a simple 0 and that makes it 90, 110 to 10, 90. Correct. Okay. Now, if there is a pole term, okay, that means 1 upon 1 plus st. Okay, what is the corner frequency? Corner frequency means same formula, 1 upon d. What happens in the magnitude plot? Let us revise. We know about magnitude plot. In the magnitude plot, slope changes by how much? Okay, in the 0 it is plus 20. In the case of pole, there is a slope change of minus 20 decibel per decade at that corner frequency, at omega c. Okay, at omega c. What about what happens in the phase plot? Okay, just reverse results will be seen. Okay, in the phase plot, you will see a slope change of number 1, reverse the result. First, minus 45 degree per decade, okay, at 1/10 of the corner frequency, and second, plus 45 degree per decade at omega, which is 10 times the corner frequency. Okay, just reverse this, plus to minus and minus to plus. Okay, now let's understand this with the help of the given question. The asymptotic Bode phase plot of GS equal to K upon S plus 0.1, S plus 10, S plus P1 with K and P1 both positive is shown below. Okay, what is the value of P1? Let me write down this GS once again. What is the GS given to me? What is the GS is K. That means there are no zeros term, only pole terms, S plus 0.1, S plus 10, and S plus P1. We want to find what is the value of P1. Okay, so there are only poles, there are no zeros. Okay, there are no zeros, number 1. Okay, then there are poles. Okay, what is the corner frequency due to pole? Okay, so as I told you, see, what I have told you is, if it is 1 plus st term, what 1 plus st or 1 upon 1 plus st, if it is 1 plus st or 1 upon 1 plus st, corner frequency formula is same. That is 1 upon t. If it is in the non-standard form, s plus a or 1 upon s plus a, then what is the corner frequency? Then it is directly a. That's what I told you. Then you can directly write a, because see again, if you take a common, then it becomes the time constant form. If you take a common, then it becomes the time constant form. Correct? Okay, then you can say that the time constant is 1 by a, so corner frequency, which is reciprocal of time constant, will be a. So if it is non-standard form like s plus a, the corner frequency is directly a. Okay, so here all the terms are in s plus a format. So what are my corner frequencies? 0.1, 10 and P1. Okay, but because the phase plot is given, what I told you, with respect to pole, there will be slope change of minus 45 and plus 45. Two slope changes will occur due to a single pole. Okay, minus 45 at 1/10 of corner frequency, plus 45 at 10 times the corner frequency. Okay, so what will I write here? Let me come back here. Okay, there should be slope change of, okay, there should be slope change of minus 45 degree per decade. At what frequencies? At 1/10 of omega c. Okay, so what is 1/10 of omega c? Okay, so first will be 1/10 of 0.1, that is 0.01. Okay, then 1/10 of 10 will be 1. Okay, and 1/10 of P1 will be P1 by 10. Then there will similarly be slope change of, okay, plus 45 degree per decade, where at omega equal to 10 times. At 10 times the corner frequency, slope will change by plus 45. Okay, so what frequencies will come up here? 10 times the corner frequency. So 10 times into 0.1 is 1. Okay, 10 times of 10, 100. 10 times of P1 is 10 P1. Okay, now you see here one important result is omega equal to 1. Okay, at omega equal to 1, you say that slope change of minus 45 will also occur, plus 45 will also occur, and minus 45 plus 45 cancel, 0. Okay, so at omega equal to 1, okay, there is no slope change. As you see in the plot also, see, this is a slope change. See, this is a line, then it changes in, then it bends. Bends up or bends down means slope changes. Okay, so this is a slope, this is a slope change, then it continuously goes here, next slope change, then the slope change, it bends up. Okay, and then there's another slope change. These are the four slope change. Do you see any slope change at omega equal to 1? No, because at omega equal to 1 changes. So there should be 4 slope change points. Okay, 0.01, and you're able to see what is the first slope change point? 0.01. Okay, then there should be a slope change of at 100 also. See, at 100 also. So yeah, I am able to match 100 also. Then 0.1 and 10 also are slope change points. 0.1 and 10 also are slope change points. Okay, so what are the other slope change points? 0.01 I have highlighted, 100 I have highlighted, 1 will be cancelled. P1 by 10 and 10 P1. This means that P1 by 10 will come first. Now this is smaller. That means this should be P1 by 10, and this means this other point, this should be 10 P1. From any of them you can find the value of P1. Isn't it? 0.01, P1 by 10, 10 P1 and 100. Okay, so from here P1 by 10 is 0.1. So what is P1? P1 by 10 is 0.1. So what is P1? 10 into 0.1 is 1. Or 10 P1 is 10. So P1 is 1. What is the value of P1? Is 1. Okay, this is on the Bode asymptotic phase plot. Bode asymptotic phase plot. Answer is 1. Tell me if any doubts. Tell me if you have doubts here. Okay. Okay, fine. Yes, Sharma. Okay, let's then move ahead towards the next variety of question. Look into it. Gate 23 EC 2 marks. Okay, gate 23 EC 2 marks. The asymptotic magnitude Bode plot. See, majority of the questions you will find on magnitude plot, but sometimes they can ask on asymptotic phase plot, so that also you should know. Okay, and I have revised out important formula. What happens due to 0? due to pole. There are two slope change points, 1/10 and 10 times. 1/10 of omega c and 10 times omega c. Okay, now again this is a magnitude Bode plot. The asymptotic magnitude Bode plot of a minimum phase system, okay, shown in the figure. The transfer function of the system is of the form k s plus z power a upon s power b s plus p power c. Okay, where k, z, p, a, b, c are positive constants. What is the value of a plus b plus c? Okay, so it's like the transfer function analysis only, but converted to NAT format. What is a plus b plus c? Okay, so primarily simple only. Now see, initial slope minus 20. Initial slope is minus 20 n, which is minus 20. So n equal to 1 pole at origin. Now here this is actually n. S power n is written as s power b. So this is equal to n, which is 1. Okay, there is 1 pole at origin. Okay, so b is obtained. B is obtained. Now you see, okay, there is a slope change here. Okay, the slope was minus 20. Now it is parallel to x-axis. That means slope is 0. From minus 20 to 0 means the slope is increased by plus 20. Na? Minus 20 plus 20 will give 0. Minus 20 plus 20 will give 0. That means there is a slope increase, and increased slope means 1, 0. Okay, increase in plus 20 means there is a 0. Okay, at what frequency? At omega 1. That is unknown. We will find that. We will do some efforts to find omega 1. Okay, we will do some efforts to find omega 1. Okay, then again, what happens here? What happens here? Okay, slope was 0. What happens here? You see here. What happens here? Slope was 0. Now becomes minus 40. Slope was 0. Now becomes minus 40. The slope decreased means pole. How many poles? 40 means 2 poles. Okay, so there are 2 poles. At what frequency? At omega 2. Okay, at what frequency? That is at omega 2. Okay, now what is that omega 1 or omega 2? Let's try to work out on that. Okay, let's try to work out. Actually not required. Because I only want the power a and c. And maybe we'll not able to find also. Data is not sufficient to find omega 1, omega 2. But we need what? Okay, this is g of s. G is missing here. No problem. I'll write down. Okay, so because of this much of analysis, what we can say? Okay, what we can say is the GSHS will be of the format k. Okay, some k. Okay, they only say GS here. That means unity feedback is considered. Suppose, no problem. Is some k. Okay, into how many zeros? Where is a 0? There is a 0 at omega 1. Okay, so 1 plus s by omega 1. 1 plus s by omega 1. How many 0? A single 0. That means power 1. Divided by s power. How many poles at origin? 1. Okay, so s power 1. Then there are 2 poles at omega 2. So 1 plus st. Time constant is 1 upon corner frequency. So 1 plus s by omega 2. But how many these poles? These are 2 poles. So power 2. Now we have ABC everything. Okay, now we have, okay, this is A, okay, this is B, and this is C. So the answer should be 1 plus 1 plus 2, 4 it should be. Okay, A plus B plus C. Okay, A is 1, B is 1, C equal to 2. So answer is actually 4 then. Okay, answer is actually 4. A plus B plus C. Yeah, correct. It is 4. Okay, Sumit, just recheck the calculation once. Today we have little extended session, Govind Rao. Okay, maybe I think, I don't know, maybe 10-15 minutes more. Yes, Sharma, correct answer. It's 4, correct. All right, let's move ahead to the next question. Okay, let's take up another variety. So see, this was same transfer function analysis, finding out the corner frequency of poles and zeros, finding the initial slope, but finally converted to a NAT format. Okay, finally converted to a NAT format, numerical answer type format. Yeah, let's come up here. The Bode asymptotic magnitude plot of a minimum phase system is shown in the figure. If the system is connected in unity negative feedback, the steady state error, see, important one. The question comes on steady state error and they clearly mention unity negative feedback, because we can do the error analysis directly for unity feedback. If it is non-unity, then also we can find error, but we have to convert to unity feedback for the reasons I explained you earlier. You can refer to the steady state error classes. Okay. Yes, Ashish Kumar. Okay, Raju, Sharma, Sumit. Correct answers for the previous question. Good going. Okay. So system is connected in unity negative feedback. What is the steady state error of the closed loop system to unit ramp input? Now let's learn here. Okay, let's learn here. The Bode asymptotic magnitude plot of a minimum phase system is shown. Okay, now you see what is the initial slope. Okay, now what is the initial slope? Can we find out the initial slope? See here, what is this slope? And this slope here is the initial slope. This slope here will be known as initial slope. How much is the initial slope? See, pick up these 2 points. You can take up to here also, but simple. Pick up these 2 points. Magnitude change is 26.06 to 6.02. 26.02 to 6.02. The how much? How much is this? Minus 20 dB drop, 26 to 6. So there is a decrease of minus 20. Okay, and how much is the frequency change? 0.121. That means into 10. That means 1 decade. Okay, so how much is the initial slope? Minus 20 decibel is changing for how much frequency? 1 decade. So initial slope is minus 20 decibel per decade. Initial slope is minus 20 decibel per decade. Okay. Minus 20 decibel per decade. That is the initial slope. Okay. And we know that initial slope is minus 20n. So comparing it, n equal to 1 pole of GS at origin. Okay, unity feedback. And the only GS is there. 1 pole of GS at origin. And number of poles of GS at origin when connected in unity feedback is known as type of the system. So this is type 1. This is type 1 system, correct? Okay. So that is what I told you earlier also. If it is unity feedback, okay. If it is unity feedback, then the n will also tell you the type of the system. So n equal to 1 means it is type 1. Okay, good to know that, Hemant, you are enjoying and learning. Okay, it is type 1 system, fine. Number 1 point. Okay, now because it is type 1 system, what is the steady state error for step input? Let us revise everybody. Here it is on ramp input. Okay. For step input, 0. For lower order input, 0. For higher order input, infinity. Type 1 system will give the finite error for ramp input. That is why they have asked the question on ramp. We have done all this analysis in the error class. Steady state error for ramp input will be finite. How much finite? Given by 1 upon kV. 1 upon kV. And steady state error for parabolic. The question is only on ramp, but just revising it. Steady state error for parabolic input, higher order input, infinite. Okay, so here question is find the steady state error for ramp input, which is actually 1 upon kV. And what is kV? Okay, kV is equal to k. kV is equal to k in the standard transfer function. In the standard form. Okay, the k of the standard form. Okay, and Bode plot, as I told you, will usually sketched by considering the standard form. Standard form means time constant form. Okay, so what is the value of k? Can you find the value of k? We need kV. Okay, that means which is equal to k. That means I need the value of k. How do you find k? Now, I'll tell you 2 methods for k. One was already told. Method number 1 for k. Method number 1, initial part formula. Minus 20 n log omega plus 20 log k. Magnitude is minus 20 n log omega plus 20 log k. So what I can do is, this is the initial part. Now you see, at omega equal to 1, the magnitude is 6. Let's use this point. Maybe k will come from here. Okay, initial part is the part up to the first corner frequency. This is the first time where slope is changing. Okay, so I can use any frequency up to this. Let's use omega equal to 1. Why omega 1? Because log 1 is 0. Simple value will come. So what I will do is, at omega equal to 1, magnitude is 6 dB. 6.02, or let's approximately take 6. Okay, So, and how much is n? N is already I told you is 1. So 6 is equal to minus 20 into log 1 plus 20 log k. Okay, so log 1 is 0. That is the reason I chose omega 1. Okay, log 1 gives simple value. Okay, so 20 log k is 6. Okay, so what will be k? So log k is 6 by 20. So k will be 10 raised to the power 6 by 20. For that, we can refer to our calculators. Okay, it's approximately 2. K is approximately 2. Okay, another method. Okay, see, normally initial part formula, okay, the initial part magnitude formula mostly will help you solve K. Okay, but still I'll tell another method here. Method number 2. What is that method number 2 is? I'll write down. The method number 2 is derived using this formula only. Okay, and I say that initial part intersects, okay, initial part intersects 0 dB axis. 0 dB means x axis, where magnitude is 0. On the x axis, magnitude is 0, now y is 0. The initial part intersects the 0 dB axis at omega, at the frequency omega, which is k power 1 by n. Okay, or we can say that we can say that k will be equal to omega power n. So how to find k? Okay, find the frequency omega, where the initial part intersects, okay, the 0 dB axis. And here this approach is simpler. Why? Because clearly seen, this is the initial part, okay, which intersects the x axis at omega 2. Okay, so here omega is 2. Okay, so what is k? K is omega power n, omega is 2 and n is 1. Okay, so k is 2, directly obtained. K equal to 2 is directly obtained. Okay, and if k is 2, steady state error is 1 upon kV. kV equal to k of the standard form. K is 2, so steady state error 0.5. Steady state error calculation from Bode plot, that is also covered. The steady state error is 0.5. The steady state error is 0.5. The steady state error is 0.5. Hope that is clear to you. Yeah, 2 is derived from method 1 only, Govindrao. This is derived. See, initial part intersects 0 dB axis. What do I do here is, okay, I'll put magnitude 0. Okay, and then 20 n log omega is 20 log k. From that only we get this result. Okay, so the method 2 is derived from method 1. Okay, but whenever, okay, this frequency is given to you directly, so method 2 becomes shortcut there. Whenever the initial part intersects the x axis, it is given here clearly 2. Okay, so then we can directly find k by the formula omega power n, where omega is the intersection with the x axis point, intersection of the initial part. Okay, chalo. Next question, gate 24 EE 2 marks. Okay, consider the stable closed loop system shown in the figure. The asymptotic Bode magnitude plot GS has a constant slope of minus 20 at least till 100 radian per second with the gain crossover frequency. I will take one session on phase margin and gain margin also. And when I take on phase margin, okay, then we will have the gain crossover frequency coming up. Okay, I'll just tell the simple definition right now, but I will take one more session where I'll only discuss about phase margin and gain margin. Direct question of phase margin, gain margin, or through Bode plots or through Nyquist plots, all those will be covered. Okay. So consider the stable closed loop system shown in the figure. The asymptotic Bode magnitude plot has a constant slope, okay, of minus 20, okay, at least till 100 radian with the gain crossover frequency. Now, what is gain crossover frequency? Just one line I will tell right now. Okay, what is this gain crossover frequency? Okay, it is the frequency. Okay, it is the frequency at which, okay, the magnitude, okay, of gj omega h j omega, that is mod gj omega h j omega, is unity, is equal to 1. That means in log scale, okay, that means in log scale, in decibel, okay, how do we calculate the magnitude in decibel? 20 log mod gj omega h j omega. Okay, so how much is going to be this value? So mod gj omega h j omega is 1 and log 1 will be 0. So in terms of Bode plot, we can say that gain crossover frequency is the frequency at which magnitude is 0 dB. Absolute value of magnitude is 1, but in decibel scale, when you convert to the log scale, it is 0. Okay. So what they are telling is, okay, the Bode magnitude plot has a constant slope of minus 20 at least till 100. Okay. On the basis of this, okay, let's try to have this rough sketch of the Bode magnitude plot. The rough sketch of the Bode magnitude plot, where they say that it has a slope of minus 20 at least till 100 with the gain crossover frequency, that means 0 dB point, okay, at how much? Gain crossover frequency is 10, okay, and the slope is minus 20 at least till 100, okay, at least till 100. So something like this. Something like this. This is the slope, minus 20 decibel per decade. Okay, this is the gain crossover frequency. This is omega g, gain crossover frequency, which is 10. Okay, and suppose, let's say this is frequency 100, and at least up to this frequency, the magnitude, the slope is minus 20. Okay, at least till 100 and gain crossover frequency is 10. The asymptotic Bode phase plot remains constant at minus 90 degree at least till 10. Okay, now what happens after this? Okay, the slope is minus 20 decibel per decade till 100. After this, the slope may increase, may decrease, not given, not mentioned. What happens after this? Not mentioned. Okay, but not required also, because see, finally the question is on steady state error. Finally, the question is on steady state error, and very clearly you see that because it is steady state error question, they have clearly given you a unity feedback system, right? HS is 1, feedback is unity. So what I need, I don't even need the phase plot also, not required, because from the magnitude plot only, dear, from the magnitude plot only, this is initial slope, which should be minus 20n. This is the initial slope, minus 20n is minus 20, so n equal to 1. N equal to 1, and it is unity feedback, so I can directly say that this is type 1. Okay, and that is why the question is steady state error, again due to ramp input. Okay, because it is type 1. Okay, because it is type 1, what is the steady state error? Due to ramp, 1 upon kV. Due to step is 0, due to parabolic is infinity. Okay, and 1 upon kV, where kV will be k in the time in the standard form. Now what is k? We can find the value of k from here, na? Okay, we can find the value of k from here. Okay, omega equal to 10, okay, is the 0 dB intersection point. Okay, this is the frequency where you intersect the 0 dB intersection. This is the 0 dB intersection point. Okay, and if you know the 0 dB intersection point, then the k is given by what formula? As I told you, method number 2, shortcut. Okay, the k is given by the formula omega power n. Omega is how much? Omega is 10. Okay, and n is how much? N is 1. So k is 10. So my answer is 1 by 10. Okay, for the error, that means error is 0.1. The final answer for the error is 0.1. Final numerical answer type data, it is 0.1, dear. Got it? Zero 0.1. It is 0.1. Okay, done. So hope with every question you are learning something. Okay, important update that the next regular offline batch, okay, if you want to prepare for GATE 25, the regular offline course, okay, for ECEE starts this 27th of September. And for any queries about the offline batch, okay, the offline batch where you study, where you enjoy the charm of studying directly under the supervision of faculty between hundreds and thousands of students. So you get that competitive atmosphere, okay, competing each other. For any queries about this batch, you can contact 95156 94043, or you can directly visit our website ominstitute.com. Also, dear, if in case you can't travel to Hyderabad for the offline course but still want to study under the same faculty team, same content, same variety of questions, okay, delivered by the same faculty, so you can also join our live batches, okay, the online live batches, which is also live, means again, directly one-to-one, you can interact with the faculty and you can get your doubts and everything cleared immediately. Available for GATE 25, GATE 26 with the fees mentioned. And these live batches you can watch on our live app, okay, app also, or on the browser ominstitute.live, okay. And the offline batches for AE just started 22nd, that is yesterday, okay, the AP Transco, AP Discoms, and the Telangana Transco examination. So all these AE offline batches, okay, again these are offline batches at a Hyderabad center, just started 22nd of September, okay, right. Yes, depends, Sharma, on how much you have covered till now. At least some part you might have done till now. So if you let me know that, or you can, for more detailed discussion, you can also connect with me in Telegram. Not necessarily in the group, but you can personally DM me in Telegram. I'll reply you there. Yes, guys. So like every session, I'll share you today's PDF also, and that will be in the Telegram. Okay, if you're not connected in my Telegram, this is the link to join the Telegram. You can just type this link and get connected in the Telegram group. And all the PDFs will be password protected. Okay, because if you're watching, okay, then only you need the PDF. And if you're watching, you get the password. So what is the password for today? A lot of slope calculations happened today. So the password for today's PDF, randomly I made it is slope, SLOPE, everything in small. SLOPE, everything in small letter. SLOPE. Okay, this is the password for the today's PDF. Whatever we discuss, question, solution, revision, formulas, discussions, details, everything will be available in this group. Okay, dear. Chalo, that's it. With this, I'll sign off for today, and we'll have next session. We'll have on Nyquist plots. We'll have on gain margin, phase margin. All